Jake Morrison pressed his face against the transport window and watched the massive crystal structure grow larger before him. The Zentari Academy floated in perfect orbit around the gas giant Kepler 442b, its transparent walls catching and bending the light from 3 different suns. The building stretched for miles in every direction, with countless levels spiraling upward like a frozen tornado made of pure diamond. His hands were sweating inside his dress uniform gloves. Jake had dreamed of this moment for 5 years ever, since Earth's Space Command announced the first human exchange program with the galaxy's most prestigious learning institution. Out of 3 billion applicants from Earth, only 2 humans had been selected. Jake was one of them. "First time seeing it?" asked Lisa Reynolds, his fellow exchange student. She sat across the aisle, her own face glued to her window. Lisa was backup navigator class, just like Jake, but her test scores were actually higher than his. The selection committee had chosen Jake for reasons he still did not understand. "Yeah," Jake replied, his voice barely above a whisper. "Hard to believe. We made it here." The transport ship docked with a soft thud that Jake felt through his boots. Around them, other passengers began gathering their belongings. Jake recognized several alien species from his preparation studies. A group of hexapods moved with mechanical precision, their 6 arms working in perfect coordination to handle multiple bags at once. Their insect-like heads turned toward Jake and Lisa with what looked like curiosity, though Jake could not be sure about alien facial expressions. Near the front of the transport sat 3 Vorthok students. Their crystalline bodies hummed with soft musical tones that Jake had learned was their form of communication. The light passing through their transparent forms created rainbow patterns on the walls. According to his briefing materials, Vorthok could process mathematical equations faster than most computers. A tall figure approached Jake and Lisa as they stood in the docking bay. The alien was humanoid but stretched nearly 8 feet tall, with blue-tinted skin and eyes that seemed to glow with their own light. This had to be a Zentari, the species that built and operated the academy. Human students Morrison and Reynolds. The alien said in perfect English, though with a musical accent that made every word sound like part of a song. "I am Director Velketh. Welcome to the Zentari Academy of Advanced Sciences." Jake straightened his shoulders and tried to look professional. "Thank you for having us, Director. We are honored to be here." Velketh studied them both for a long moment. His glowing eyes seemed to look right through Jake, as if measuring something that could not be seen. "Your species shows promise in spatial navigation, though your mathematical foundations are quite primitive. We shall see if you can adapt to our teaching methods." The word primitive hit Jake like a slap, but he kept his expression neutral. Lisa shot him a quick warning glance that said, "Don't react. Follow me." Velketh continued, turning toward a corridor that seemed to stretch forever into the crystal structure. "I will show you to your quarters and explain the Academy's basic systems." As they walked, Velketh pointed out various sections of the massive building. The Academy housed over 10,000 students from 12 different species across the galaxy. Each species had contributed their greatest mathematical and scientific knowledge to create the most advanced learning institution ever built. The hexapods provided our computational frameworks, Velketh explained as they passed a laboratory where 6-armed students worked at multiple calculation stations simultaneously. They can process parallel mathematical operations that would take other species hours to complete. They continued past another section where ghostly, gas-like beings floated through chambers filled with swirling mists. The Nephilim contribute their understanding of gravitational mathematics. They navigate by sensing the mathematical relationships between celestial bodies rather than using instruments. Jake watched the floating aliens with fascination. They moved through their environment like living equations, each motion perfectly calculated and graceful. "And your people?" Velketh asked, turning those glowing eyes back toward Jake and Lisa. "What mathematical traditions do humans bring to our academy?" Jake felt his throat go dry. Earth's greatest mathematical achievements seemed laughably simple compared to what he was seeing around him. "We have strong foundations in geometry and spatial reasoning," he managed to say. Our navigation traditions go back thousands of years. One of Velketh's eyebrows raised slightly, which Jake took as either surprise or amusement. Geometry. How delightfully basic. I suppose every species must start somewhere. They reached a section of the academy that looked different from the rest. Instead of the gleaming crystal construction, this area seemed older and less maintained. The walls were made of simple metal and the lighting was dimmer. "These will be your quarters," Velketh announced, stopping before two doors marked with human-readable numbers. "This section houses students who require additional academic support. I trust you will find it adequate." Jake realized they were being placed in what amounted to the remedial student housing. The message was clear without being directly stated. Lisa's jaw tightened, but she simply nodded politely. "Your first classes begin tomorrow morning," Velketh continued. "You will start with basic mathematical principles with Professor Meltor, followed by Introduction to Advanced Calculus with Professor Zix9. I suggest you review your preparation materials tonight. The pace here may be challenging for students from less mathematically developed worlds." After Velketh left them alone, Jake and Lisa stood in the corridor looking at their room assignments. The weight of what they had gotten themselves into was beginning to settle on Jake's shoulders like a heavy blanket. "Well," Lisa said finally, "this should be interesting." Jake managed a weak smile. "At least we are here. No human has ever gotten this far before." "True," Lisa replied, opening her door. "Though I am starting to understand why." That night, Jake lay in his narrow bed staring at the ceiling of his small room. Through his window, he could see the gas giant's swirling clouds and the stars beyond. Somewhere out there was Earth, impossibly far away. He thought about his family, his friends at the Navigation Academy, and all the people who were counting on him to prove that humans belonged among the galaxy's elite. The mathematical textbooks on his desk seemed to mock him with their complexity. Equations filled with symbols he barely recognized covered every page. Tomorrow would be his first real test of whether a human could survive in this place. Jake closed his eyes and tried to sleep, but his mind kept racing through calculations and formulas. He wondered if he had made a terrible mistake in coming here. Maybe humans really were too primitive for this level of education. Maybe he would become the laughingstock of the entire academy, but somewhere in the back of his mind, a small voice reminded him that humans had always found ways to navigate impossible situations. They had crossed oceans using nothing but stars and wind patterns. They had reached space using mathematics that these aliens considered basic. Perhaps that would be enough. Perhaps it would have to be. Jake's first morning at the academy began with a lesson in humility. He arrived at Professor Meltor's Basic Mathematical Principles class 5 minutes early, hoping to make a good impression. The classroom was a vast circular chamber with floating desk platforms arranged in concentric rings around a central teaching area. Students from various species had already claimed seats in the higher rings, leaving the bottom level nearly empty. Jake chose a seat in the second ring and activated his desk's holographic interface. The symbols that appeared were unlike anything he had seen before, even in his preparation materials. He fumbled with the controls while trying to look confident. A chittering sound made him look up. 3 hexapod students in the ring above him were watching his struggle with obvious amusement. Their insect-like heads tilted in perfect synchronization as they observed his clumsy attempts to navigate the alien interface. "Need assistance, primitive one," one of them asked in mechanical English. The universal translator made all their voices sound exactly the same, which Jake found unsettling. "I'm fine, thank you," Jake replied. Finally managing to bring up what looked like a note-taking application, Lisa arrived just as Professor Meltor entered the classroom. The professor was a Zentari like Director Velketh, but shorter and with darker blue skin. His glowing eyes surveyed the students with the detached interest of someone who had taught the same lesson thousands of times. "Today we will review multidimensional calculus as it applies to navigation through non-Euclidean space," Professor Meltor announced. Please calculate the rate of change for a vessel moving through a gravitational field that exists in 17 dimensions. Jake's heart sank. The problem appeared on his desk display as a wall of mathematical symbols that might as well have been written in an alien language. Around him, other students immediately began working, their various appendages moving across their interfaces with practiced ease. To his right, a Vortex student's crystalline body began glowing brighter as it processed the calculations. The light patterns shifting through its transparent form were apparently its method of working through complex mathematics. Within 30 seconds, the alien had reached a solution and submitted its answer. Above him, the hexapods were using all 6 of their arms to manipulate different parts of the equation simultaneously. Jake watched in fascination and growing panic as they broke the problem into smaller pieces and solved each component in parallel. Their final answer appeared on the classroom's main display just 45 seconds after the problem was given. Jake was still trying to understand what the first symbol in the equation meant. "Human Morrison," Professor Meltor called out. "Your solution, please." Every eye in the classroom turned toward Jake. He felt his face burning with embarrassment as he looked down at his blank answer screen. "I'm still working on it, Professor. Sound that might have been laughter came from the hexapod section. The Vortex students' humming grew more musical, which Jake suspected was their version of amusement. "Perhaps you would benefit from reviewing basic arithmetic before attempting advanced calculus," Professor Meltor suggested. "I can provide you with elementary mathematics textbooks suitable for developing minds." The humiliation was complete. Jake nodded silently and tried to focus on the lesson, but the damage was done. For the rest of the class, he struggled to follow even the simplest concepts while his classmates solved increasingly complex problems with casual ease. Introduction to advanced calculus with Professor Zix9 was even worse. The crystalline Vorthak professor communicated primarily through musical tones, with the universal translator providing a monotone English interpretation that made everything sound like a robot reading a mathematics textbook. Calculate the probability matrix for quantum navigation through unstable wormhole structures, Professor Zix9 intoned through the translator. Factor in temporal displacement and dimensional drift. This time Jake did not even pretend to attempt the problem. He watched helplessly as a Nephilim student named Whisper of Stars solved the entire equation without using any visible interface at all. The gaseous alien simply floated in place for a few moments, then transmitted its answer directly to the classroom computer through some form of telepathic connection. "Impressive as always, Whisper of Stars," Professor Zix9 noted. "Your species' natural ability to perceive mathematical relationships gives you significant advantages in quantum calculations." Jake glanced over at Lisa and saw that she was struggling just as much as he was. Her desk display showed several failed attempts at the problem, each one abandoned after a few minutes of futile work. The breaking point came during their third class of the day, Theoretical Physics with Professor Victor. The subject was faster-than-light travel mathematics, and Jake actually knew something about this topic from his Earth training. When the professor asked for questions about relativistic effects on navigation, Jake raised his hand. "Yes, human." "Morrison," Professor Victor acknowledged that Jake stood up, trying to project confidence he did not feel. "I was wondering about alternative approaches to calculating space-time distortion. On Earth, our physicists have developed some interesting theories about using gravitational lensing effects to create more efficient FTL corridors." The classroom fell silent. Then, starting with a low chittering from the hexapods, laughter began to spread through the room. The Vorthax students' humming became a discordant musical chaos. Even the normally serene Nephilim began producing what sounded like steam escaping from a pressure valve. Young Zentari named Velnox stood up in the highest ring of seats, his glowing eyes fixed on Jake with obvious contempt. "Human, your species still uses primitive number systems because you count on your 10 appendages. You think in base 10 mathematics like children playing with counting stones? We Zentari calculate in base 16 frameworks that your underdeveloped minds cannot even comprehend." More laughter erupted around the classroom. Velnox was clearly enjoying his moment in the spotlight. Perhaps, Velnox continued, you should return to your basic arithmetic courses before attempting to discuss theoretical physics with your intellectual superiors. One of the hexapod students joined in the attack. Humans require mechanical calculators for simple multiplication. How can such a primitive species contribute to advanced navigation theory? Whisper of Stars added its own observation through the translator's mechanical voice. Human navigation relies on crude stellar positioning rather than sophisticated gravitational field harmonics. It is like comparing a stone axe to a quantum computer. Jake felt his face burning with humiliation and anger. He wanted to defend his species, to explain that human achievements might be different but were not necessarily inferior. But standing there surrounded by beings who could solve in seconds what would take him hours to understand, his arguments felt hollow. Lisa tried to come to his rescue. Actually, human mathematics have some unique advantages in spatial visualization and pattern recognition that might complement your more advanced computational methods. But her nervous voice and obvious uncertainty only made things worse. Velnox turned his glowing gaze toward her with predatory interest. Please, Human Reynolds, enlighten us. What patterns can your primitive visual cortex recognize that our advanced mathematical frameworks cannot calculate with perfect precision? Lisa's confidence crumbled under the scrutiny. She tried to explain human navigation techniques, but her words came out jumbled and uncertain. When she attempted to work through a simple example on her desk display, she made several calculation errors that only fueled more laughter from the alien students. Professor Victor finally called for order, but the damage was done. For the rest of the class, Jake and Lisa sat in mortified silence while their classmates continued to demonstrate mathematical abilities that made human achievements look like children's games. After class, Jake and Lisa walked back to their quarters. In the remedial housing section, without speaking, the weight of their failure pressed down on them like a physical force. Around them, other students chatted excitedly about the day's lessons, discussing concepts that Jake had barely been able to follow. Maybe we should just go home, Lisa said quietly as they reached their doors. Maybe humans aren't ready for this level of education. Jake wanted to agree with her. Every instinct told him that they were out of their depth, that they had no business trying to compete with species whose mathematical abilities were centuries ahead of human development. That as he stood there in the dim corridor of the remedial housing section, something stubborn in his personality refused to give up. His grandfather had been a navigator in Earth's early space program, finding ways through asteroid fields and around dangerous radiation zones using nothing but human intuition and basic mathematics. Not yet, Jake said finally. We've only been here one day. Let's give it a little more time. Lisa looked at him with a mixture of admiration and pity. Jake, did you see what they can do? We're like cavemen trying to understand quantum physics. Maybe, Jake admitted. But cavemen eventually learned to build spaceships. That night, Jake sat at his small desk surrounded by alien mathematics textbooks that seemed to mock him with their complexity. Every page contained concepts that pushed the boundaries of his understanding. The third week at the academy had settled into a routine of daily humiliation for Jake and Lisa. They attended classes where they understood perhaps one word in 10, submitted assignments that came back covered in corrections, and endured the increasingly open mockery of their classmates. Jake had begun to seriously consider Lisa's suggestion that they return to Earth. Then Professor Zixnine made an announcement that changed everything. Students, the crystalline Vorthak professor intoned through the universal translator, today, I will present your final examination challenge. This assessment will determine your final grades and your eligibility for advanced placement in next semester's courses. The classroom fell silent. Even the normally chattering hexapods stopped their mechanical conversations. Final examinations at the academy were legendary for their difficulty. Professor Zixnine's crystal body began glowing brighter as he accessed the academy's main computer systems. A massive holographic display materialized in the center of the Classroom showing a three-dimensional map of local space. One section was marked in ominous red. Your challenge is to solve the navigation paradox of the void sector, Professor Zix9 announced. Jake recognized the name from his preparation. Studies. The void sector was a region of space that had baffled navigators for over 3 centuries. Ships that entered the area often vanished completely, and those few that managed to escape reported impossible gravitational phenomena that defied every known law of physics. As you can see, Professor Zix9 continued, manipulating the holographic display to show the sector in greater detail. This region contains gravitational anomalies that shift in unpredictable patterns. The gravitational fields change strength and direction every 4.7 standard galactic hours. Additionally, streams of dark matter flow through the area in patterns that create temporal distortions. The display zoomed in to show a tangled mess of gravitational field lines that seem to writhe and twist like living things. Jake had never seen anything so chaotic and dangerous looking. 23 different species have attempted to solve this navigation problem, Professor Zix9 explained. Each has applied their most advanced mathematical frameworks and computational systems. The Vorthic Collective used pure quantum mathematical modeling. The Hexapod Commonwealth deployed their most sophisticated parallel processing algorithms. Even the Great Zentari Mathematical Institute has been unable to find a solution. Velnox raised one of his long arms. Professor, if the greatest minds in the galaxy have been unable to solve this problem, how do you expect students to succeed? Professor Zix9's crystal body pulsed with what Jake had learned to recognize as amusement. An excellent question, Velnox. Normally, this would be purely a theoretical exercise designed to teach you the limitations of current mathematical knowledge. However, the situation has recently become more urgent. The holographic display changed to show a small blinking signal deep within the red zone of the void sector. 3 days ago, our deep space monitoring stations detected a distress signal from within the sector. A research vessel called the Stellar Wind appears to be trapped in the gravitational maze. Their last transmission indicated they have life support for approximately 2 standard weeks. The classroom erupted in surprised chittering, humming, and gasping sounds from various species. Jake felt his stomach drop. This was no longer just an academic exercise. Therefore, Professor Zix9 continued, your challenge is not merely theoretical. The Academy has been commissioned by the Galactic Rescue Service to find a solution that could save actual lives. The student or team that develops a workable navigation plan will have their solution tested in the Academy's advanced simulation systems. If successful, it will be transmitted to the rescue ships currently standing by at the edge of the void sector. Jake looked around the classroom at his classmates. The hexapods had already begun their characteristic parallel conversations, their 6 arms gesturing in complex coordination. The Vortex students' crystal bodies were glowing brighter as they began preliminary calculations. Even Whisper of Stars had stopped its usual floating motion and was hovering perfectly still in intense concentration. You have 1 standard week to develop your solutions, Professor Zix9 announced. All Academy resources are available to you. Quantum computers, mathematical databases, simulation chambers, and consultation with faculty members. Use whatever methods you believe will be most effective. As the class dispersed, Jake heard Velnox speaking loudly to a group of other Zentari students. This challenge will separate the true mathematicians from the academic pretenders. I estimate it will require calculations involving at least 47 dimensional matrices and quantum probability assessments that extend beyond normal spacetime parameters. One of his friends replied, Indeed. Only species with truly advanced mathematical capabilities will even be able to attempt meaningful solutions. It is unfortunate that some students will be completely out of their depth. The pointed look they gave Jake and Lisa made their meaning perfectly clear. That evening, Jake sat in his small room staring at the data files Professor Zix9 had provided about the void sector. The mathematical descriptions of the gravitational anomalies read like poetry written in a language he did not speak. Terms like hyperdimensional gravitational flux variance and temporal causality displacement matrices filled page after page of technical analysis. Lisa knocked on his door and entered carrying her own stack of files. Having as much luck as I am, she asked, settling into his room's single chair. I can't even understand the problem description, Jake admitted. Look at this. Calculate optimal trajectory through 17-dimensional gravitational field matrix with temporal displacement factors varying according to quantum uncertainty principles. I don't even know what half those words mean, Lisa nodded glumly. I tried accessing the Academy's quantum computers today. The interface requires mathematical frameworks I've never heard of. I couldn't even log in properly. They sat in silence for a while, listening to the sounds of intense activity from other parts of the Academy. Through Jake's window, they could see lights in other student quarters burning late into the night as alien minds tackled the challenge with resources and abilities far beyond human comprehension. You know what the worst part is? Lisa said finally. There are actual people trapped out there. Real lives depending on finding a solution. And we're so far out of our league that we can't even contribute anything meaningful. Jake thought about the research vessel's stellar wind somewhere in that chaotic maze of gravitational forces. He imagined the crew running low on life support, waiting for a rescue that depended on mathematical calculations he could not even begin to understand. Maybe we should focus on research, he suggested. Even if we can't solve the problem ourselves? Maybe we can find some approach that hasn't been tried before. Like what? Lisa asked. Jake, species with mathematical abilities centuries ahead of ours have been working on this for 300 years. What could we possibly contribute? It was a fair question, and Jake did not have a good answer. But as he looked at the data, files spread across his desk, something nagged at the back of his mind. All the previous attempts he had read about focused on predicting exactly where the gravitational fields would be at specific times. They tried to calculate precise paths through the chaos by modeling every variable with perfect mathematical accuracy. What if they're approaching it wrong? He said slowly. What do you mean? Jake picked up one of the files and flipped through pages of equations that described various failed attempts to solve the navigation problem. Look at this. Every solution tries to predict exactly what the gravitational fields will do. They want to calculate the precise position and strength of every anomaly at every moment. That makes sense, Lisa replied. How else would you navigate through dangerous space? But what if you can't predict it? Jake asked. What if the system is too chaotic for exact predictions, no matter how advanced your mathematics? Lisa frowned. Then you can't navigate through it safely. That's why it's called the navigation paradox. Jake stood up and began pacing around his small room. But humans have navigated through unpredictable environments for thousands of years. Ocean storms, atmospheric turbulence, asteroid fields that change constantly. We don't predict exactly where every air current will be. We learn to read the patterns and adapt. Jake, this isn't the same thing. We're talking about gravitational forces that can tear a ship apart. I know, Jake said, his mind racing. But what if the principle is the same? What if instead of trying to predict everything perfectly, we find ways to navigate dynamically through the chaos? Lisa looked skeptical, but Jake could see that he had her attention. For the first time since arriving at the Academy, he felt like he might be onto something that other species had overlooked. It's worth trying, he said finally. We can't compete with their computational power or mathematical frameworks. But maybe we can approach the problem from a completely different direction. Outside his window, the gas giant storm swirled. In patterns that seemed chaotic, but somehow maintained stable structures over time. Jake wondered if the void sector might have similar hidden. Jake spent the next morning in the Academy's library, but not researching advanced mathematics like his classmates. Instead, he accessed Earth's historical databases and began studying something completely different, human navigation techniques. From before the space age, he read about Polynesian sailors who crossed thousands of miles of open ocean using nothing but their understanding of wave patterns, wind directions, and star positions. He studied accounts of early aviators who learned to read air currents and weather patterns to navigate through storms that meteorologists could not predict. He examined records of the first asteroid miners who developed intuitive methods for moving through constantly shifting debris fields. All of these human navigators had faced the same basic challenge, moving safely through environments too complex and chaotic for exact prediction. They had succeeded not by calculating every variable perfectly, but by learning to read patterns and adapt in real time. Lisa found him there 3 hours later, surrounded by historical documents that seemed completely unrelated to their current problem. "Jake, what are you doing?" she asked, settling into the chair beside him. "Shouldn't you be working on gravitational mathematics?" "I am," Jake replied, showing her a diagram of ocean wave patterns from an ancient Polynesian navigation manual. "Look at this. These sailors could navigate across the Pacific Ocean by reading the way waves reflected off distant islands. They didn't calculate the exact position of every wave. They learned to recognize patterns that told them where they were and where they needed to go." Lisa studied the diagram with growing interest. That's actually pretty sophisticated spatial reasoning. But how does it apply to the void sector? Jake pulled up the data files on the gravitational anomalies and spread them across the table. "What if we stop trying to predict exactly where the gravitational fields will be and start looking for patterns in how they move?" "Patterns like what?" "I don't know yet," Jake admitted. "But look at this data from previous observation missions. Everyone focuses on the chaos, but chaos often has underlying structures. Ocean storms look random, but they follow predictable patterns based on pressure systems and water temperature. Maybe the void sector has similar hidden structures." They spent the rest of the day analyzing the observation data from a completely different perspective. Instead of looking at gravitational field strengths and positions, they examined the timing and sequences of changes. Instead of trying to model exact mathematical relationships, they looked for recurring patterns and cycles. Slowly, something began to emerge from the data. The gravitational anomalies did not move randomly. They followed complex but repeated sequences, like a vast three-dimensional dance with rules that could be recognized even if they could not be calculated precisely. "Jake, look at this," Lisa said, pointing to a pattern she had identified in the temporal displacement data. "The distortions happen in waves that sweep across the sector every 2.3 hours. They're not random bursts. There's a rhythm to them." Jake felt his excitement growing. "And the gravitational field rotations follow spiral patterns that repeat every 9.4 hours. Not perfectly, but close enough that you could anticipate the general flow. They worked through the night, mapping patterns that previous researchers had ignored because they were not mathematically precise enough for exact calculations. But for dynamic navigation, approximate patterns might be sufficient. By morning, they had identified 17 different recurring patterns in the void sector's behavior. None of them were perfect predictors, but together they created a framework for understanding how the chaotic environment moved and changed over time. "It's like reading weather patterns," Jake said as he sketched out a three-dimensional diagram showing how the various cycles interacted. "You can't predict exactly where every cloud will be, but you can anticipate when storms will form and which direction they'll move." The next step was figuring out how to use these patterns for actual navigation. This was where Jake's training as a human navigator finally became useful. Instead of calculating exact trajectories, he began thinking about dynamic course corrections and adaptive routing. "We plot a general path based on the current pattern state," he explained to Lisa, drawing navigation routes on his diagrams. "Then we monitor the pattern changes and adjust course in real time, like sailing through a storm by reading the wind and waves instead of following a fixed course." Lisa caught on quickly. "And if the patterns shift in unexpected ways, we have backup routes based on alternative pattern combinations." They began developing what they called a pattern navigation system. Instead of requiring precise mathematical predictions, it used geometric relationships and spatial reasoning to navigate through chaos by reading and responding to environmental patterns. The mathematics involved were surprisingly simple, basic. trigonometry for calculating angles and distances, elementary physics for understanding momentum and trajectory changes, spatial geometry for visualizing three-dimensional relationships. All concepts that any human navigator would understand. The brilliant part, Jake realized, is that this approach actually works better when the environment is chaotic. Precise mathematical models break down in chaos, but pattern recognition becomes more important. They tested their ideas using the Academy's basic simulation systems, the ones designed for elementary navigation training, while their alien classmates used quantum computers and advanced mathematical modeling systems. Jake and Lisa worked with simple geometric displays and basic physics calculations. Their initial tests were encouraging. The pattern navigation system could guide a virtual ship through simplified versions of the void sector's gravitational maze. It was not perfect, and it required constant adjustments, but it worked. "We need to test it with the full complexity of the real sector," Lisa said. "But we'll need access to the advanced simulation chamber for that." This was a problem. The advanced simulation chambers were reserved for serious research projects, and Jake doubted that the Academy faculty would take their primitive approach seriously enough to grant them access. "We'll have to request time through Professor Zix9, Jake said. "Maybe if we can explain our approach clearly enough, he'll at least let us try." That afternoon, they prepared a presentation of their pattern navigation concept. Jake created simple diagrams showing how human navigators had solved similar problems throughout history. Lisa prepared mathematical demonstrations using basic geometric principles to show how pattern recognition could substitute for precise calculation in chaotic environments. They knew it would be a hard sell. Their approach looked laughably simple compared to the advanced mathematical frameworks their classmates were developing. But they also knew it was their only chance to contribute something meaningful to the rescue effort. As Jake put the finishing touches on their presentation, he thought about his grandfather's stories of early space navigation. Those first human pilots had reached the stars using mathematics that these aliens would consider primitive. They had succeeded not because they had the most advanced technology, but because they had learned to think creatively about impossible problems. "Ready?" Lisa asked, gathering up their materials. Jake nodded. "Ready as we'll ever be." The next morning, they would present their pattern navigation system to Professor Zix9 and request access to the advanced simulation chambers. It was a long shot, but it was the best shot they had. Outside Jake's window, the gas giant storms continued their eternal dance, following patterns too complex for exact prediction but simple enough for patient observation to understand. Jake hoped that the void sector might be similar, and that human pattern recognition skills might be enough to save the lives of the crew trapped somewhere in that chaotic maze. It was time to find out if thousands of years of human navigation experience could compete with the galaxy's most advanced mathematics. Jake suspected that his grandfather would have liked those odds. The presentation day arrived with the weight of a final judgment. Jake and Lisa entered the main lecture hall to find it packed with students and faculty from across the Academy. Word had spread that final solutions to the Void Sector Challenge would be presented today, and apparently everyone wanted to witness either breakthrough discoveries or spectacular failures. Professor Zix9 stood at the center of the circular chamber, his crystalline body pulsing with soft light as he addressed the assembly. "Today we will examine solutions to the navigation paradox of the void sector. Each presentation will be tested in our advanced simulation systems. The Academy's most sophisticated computers will model the full complexity of the gravitational anomalies to determine the viability of proposed solutions." Jake felt his stomach churning as he looked around the room. The other students had prepared presentations that looked like works of art. Holographic displays showed mathematical equations that stretched across entire walls. Three-dimensional models demonstrated computational frameworks that seemed to bend space itself. The hexapod students had synchronized their 6 arms to manipulate multiple holographic interfaces simultaneously, creating a dazzling display of parallel processing power. Velnox was scheduled to present first. The young Zentari approached the central presentation area with obvious confidence. his glowing eyes surveying the audience like a performer taking the stage. "Fellow scholars," Velnox began, his musical voice carrying clearly through the chamber, "I present the Zentari Hyperdimensional Navigation Protocol. This solution employs base 16 mathematical frameworks integrated with quantum probability matrices to predict gravitational anomaly positions with 99.7% accuracy." His presentation was stunning. Mathematical equations flowed across. Holographic displays like living art, showing calculations that Jake could not even begin to understand. Velnox demonstrated how his protocol could model the behavior of the void sector's gravitational fields in 17 different dimensions simultaneously, creating a perfect mathematical map of the chaos. By calculating the quantum probability states of all gravitational anomalies across a 47-dimensional matrix, Velnox explained, we can predict their exact positions at any given moment and plot a precise navigation route through the safest possible path. The audience was clearly impressed. Faculty members from various species hummed, chittered, and glowed with approval as they watched the elegant mathematical demonstration. Professor Zix9 activated the advanced simulation chamber. The room filled with a three-dimensional holographic representation of the void sector, complete with writhing gravitational fields and chaotic energy patterns. A virtual rescue ship appeared at the edge of the sector, ready to test Velnox's navigation protocol. For the first few minutes, the solution worked perfectly. The virtual ship followed Velnox's calculated route through the gravitational maze, smoothly avoiding the most dangerous anomalies. Jake had to admit it was impressive to watch, then something went wrong. One of the gravitational fields shifted slightly from its predicted position, creating a cascade of changes throughout the system. Velnox's precise calculations, based on perfect mathematical predictions, could not adapt to the unexpected variation. The virtual ship found itself trapped between two gravitational anomalies that were not supposed to exist in those positions. "Simulation failure," Professor Zix9 announced. "The protocol cannot compensate for deviation from predicted parameters." Velnox's glowing eyes dimmed with disappointment, but he maintained his composure. "A minor calibration issue. With more processing power, the calculations could be refined to account for such variations." The next presentation came from the Hexapod team. Their solution used massive parallel processing to calculate millions of possible routes simultaneously, selecting the optimal path based on real-time analysis of changing conditions. Their presentation was a marvel of computational efficiency, with six-armed aliens manipulating dozens of calculation streams at once, but their simulation also failed. The parallel processing system became overwhelmed by the sheer chaos of the void sector, creating feedback loops that crashed the navigation system entirely, one by one. Each presentation failed in the simulation chamber. The Vorthax students' pure quantum, mathematical approach created elegant solutions that worked perfectly in theory, but could not handle the unpredictable reality of the gravitational anomalies. Whisper of Stars telepathic probability sensing provided amazing insights into the sector's behavior, but could not translate those insights into actionable navigation instructions. Each failure was more sophisticated than anything Jake could have imagined, but they were still failures. The virtual rescue ship remained trapped at the edge of the void sector while the clock continued counting down toward the real ship's life support deadline. Finally, Professor Zix9 called Jake and Lisa to the presentation area. Jake felt every eye in the chamber turned toward them with expressions ranging from curiosity to barely concealed amusement. Velnox was whispering something to his friends that produced musical laughter from the Zentari section. "Human students Morrison and Reynolds," Professor Zix9 announced. "Please present your proposed solution." Jake activated his simple presentation display and immediately felt the change in the room's atmosphere. Instead of complex holographic equations and multidimensional mathematical frameworks, his display showed basic geometric diagrams and simple pattern charts that looked primitive compared to what had come before. "We call it pattern navigation," Jake began, his voice steadier than he felt. Instead of trying to predict exactly where gravitational anomalies will be, we identify recurring patterns in how they move and navigate dynamically through the chaos. A sound that was definitely laughter came from the hexapod section. Jake ignored it and continued. Human navigators have used similar techniques for thousands of years to move through unpredictable environments like ocean storms and asteroid fields. We don't calculate the exact position of every obstacle. We learn to read the patterns and adapt in real time. Jake's presentation showed how they had identified 17 different recurring patterns in the void sector's behavior. The mathematics involved were embarrassingly simple compared to what had come before: basic trigonometry, elementary physics, and spatial geometry that any Academy freshman could understand. The key insight, Lisa added, taking over the presentation, is that chaotic systems often have underlying structures that can be recognized even when they can't be calculated precisely. Our approach works with the chaos instead of fighting against it. Professor Zix9 studied their simple diagrams. With what Jake interpreted as polite skepticism, "Your mathematics appear quite elementary? How do you account for the complex gravitational interactions that have defeated more sophisticated approaches?" "We don't try to account for everything," Jake replied. "We identify the major patterns and navigate around the unpredictable elements. Like sailing through a storm by reading the wind instead of calculating the exact position of every air molecule." The chamber had fallen silent. Jake could feel the weight of judgment from hundreds of alien minds that had just watched far more sophisticated solutions fail completely. "Very well," Professor Zix9 said finally. "Let us test your pattern navigation approach." The simulation chamber activated again, showing the same chaotic maze of gravitational anomalies that had defeated every previous solution. The virtual rescue ship appeared at the sector's edge, ready to attempt Jake and Lisa's navigation protocol. Instead of following a predetermined path, the ship began moving through the gravitational maze by reading and responding to the pattern. Changes in real time. When gravitational fields shifted unexpectedly, the navigation system adapted, finding new routes based on alternative pattern combinations. Jake watched with growing amazement as his simple geometric calculations guided the virtual ship deeper into the void sector than any previous attempt had achieved. The ship moved through the chaos like a dancer following music that only it could hear, adapting smoothly to changes that would have destroyed more rigid navigation protocols. "Fascinating," Professor Zix9 murmured as the ship continued its progress. "The system is actually using the chaotic elements to its advantage, riding gravitational currents instead of fighting them." The simulation continued for what felt like hours but was probably only minutes. The virtual ship navigated through layer after layer of gravitational anomalies, following Jake's pattern recognition protocols and Lisa's adaptive routing algorithms. When it finally reached the center of the void sector and successfully extracted the simulated crew of the stellar wind, the chamber erupted in surprised sounds from various species. "Simulation successful," Professor Zix9 announced, his crystalline form glowing brighter than Jake had ever seen it. "Navigation time, 47 minutes, 32 seconds. Estimated crew extraction, complete with 0 casualties." The silence that followed was deafening. Jake looked around the chamber at faces that showed expressions he had never seen before, alien minds struggling to process the fact that the galaxy's most challenging navigation problem had been solved using mathematics that their children learned in elementary school.